Hello everyone, my name is Rakshita. I am from Sri Venkateshwara College of Engineering from the Department of Electronics and Communication Engineering, third year. Today I am going to discuss about the subject called renewable energy sources. In this subject I am going to discuss about the topic of solar cell, the construction and working of solar cell. So now let's see what is solar cell. A solar cell is defined as an electrical device that converts light energy into electrical energy through the photovoltaic effect. A solar cell is basically a PN junction diode. Solar cells are a form of photoelectric cells defined as a device whose electrical characteristics such as current, voltage and resistance vary when exposed to light. Individual solar cells can be combined to form modules commonly known as solar panels. The common single junction silicon solar cell can produce a maximum open circuit voltage of approximately 0.5 to 0.6 volts. By itself, this isn't much, but remember the solar cells are tiny. When combined into large solar panel, considerable amounts of renewable energy can be generated. This is the diagram of the solar cell. So now let's see the construction of solar cell. A solar cell is basically a junction diode, although its construction is little bit different from conventional PN junction diodes. A very thin layer of P-type semiconductor is grown on a relatively thicker N-type semiconductor. When we then apply a few finer electrodes on the top of the P-type semiconductor layer. And the below is the given diagram for the construction of the solar cell. So now let's see the working of solar cell. These electrodes do not obstruct light to reach the thin P-type layer. Just below the P-type layer there is a PN junction. We also provide a current collecting electrode at the bottom of the N-type layer. The entire assembly by thin glass to protect the solar cell from any mechanical shock. When light reaches the PN junction, the light photons can easily enter in the junction through very thin P-type layer. The light energy in the form of photons supplies sufficient energy to the junction to create a number of electron-hole pairs. The incident light breaks the terminal equilibrium condition of the junction. The free electrons in the depletion region can quickly come to the N-type side of the junction. Similarly, the holes in the depletion can quickly come to the P-type side of the junction. Once the newly created free electrons come to the N-type side, cannot further cross the junction because of the barrier potential of the junction. Similarly, the newly created holes once come to the P-type side cannot further cross the junction, become the same barrier potential of the junction. As the concentration of electrons becomes higher in one side, that is N-type side of the junction, and the concentration of the holes becomes more in another side, that is P-type side of the junction, the PN junction will have like a small battery cell. A voltage is set up which is known as the photovoltage. If we connect a small load across the junction, there will be a tiny current flowing through it. So this is the diagram which shows the working of the solar cell. Here we have the metal contact, N-type semiconductor, P-type semiconductor. Between N and P-type we have depletion region. And we have photons, and we have the voltage and current passing through it. Thank you for watching my video. Please do like the video, share the video and subscribe to my channel.